Hi, class. This is our first lecture, chapter 1. It's kind of an introductory chapter. So I'll be recording this lecture, and you can follow along with the PowerPoints on your screen. Some of the future recorded lectures will be on YouTube, and some of them may be on OneDrive. It just kind of depends on the chapter, so I hope you're able to view them well. First of all, about me. So I am local to the Central Coast from San Luis Obispo. I have my degree in microbiology and nutrition. I first went to study biology, but then switched because I was really interested in microbiology. So I wanted to go a little bit deeper into the smaller things. And then I had always had kind of an interest and fascination with food, so I came back and studied nutrition. I am a registered dietitian, and I did my dietetic internship at Cal Poly, and I have been a dietitian since 2008. My first job was at Hancock Community Hospital in the Central Valley of California, and I worked out there for a little while. I've also worked at Arroyo Grande Medical Center, at DaVita, which is a dialysis center, and at Cal Poly. I am a certified nutrition support clinician, which means I have advanced specialization in tube feeding and IV nutrition for patients who might need that type of support. I'm a diabetes educator, and like I said, I am native to San Luis Obispo. All right, so let's talk a little bit about nutrition. You can follow along in your textbook. Some of these slides have page numbers associated with them. Some do not. Depending on which edition of the text you're using, the page numbers should match, but it just kind of depends if you're using 13th, 14th, or 15th edition of the text. Some of the things we're going to be talking about today. All right, so let's start with some definitions. Nutrition is the science of foods and the nutrients and other substances they contain and of their actions within the body. In addition to this, it's the study of human behaviors related to food and eating. And you can have good nutrition, adequate nutrition, or you can have poor nutrition, excessive nutrition, or undernutrition. And we're going to talk about some of those things coming up. Diet. Diet is a term used to describe foods and beverages a person eats and drinks. And a lot of times people refer to a diet as something they're doing to try to lose weight, but that's not necessarily the case. A diet is literally what you eat and drink kind of on a daily basis. And maybe you are on a weight loss diet, but maybe you're just on kind of a standard American diet. So, is nutrition important for you? When did it become important? And why do people choose the foods that they eat? I hope you said that nutrition was important to you. For many of you, although you may not know it, it began to be important when you were just a baby, developing in your mother's belly. And so prenatal nutrition is actually very vital in time where nutrition is very important. The nutritional status of your mother also played a role in your development. And then, of course, when you were born, nutrition has played a role in your life, whether you've realized it or not. But everybody has to eat. And so it's one of the reasons I like nutrition is because it's so pertinent to everybody. Why do people choose the foods that they choose? The number one reason for people choosing the foods that they do is preference. We choose them because we like them. There are many additional factors such as habit. For example, maybe you always eat cereal and a banana for breakfast and coffee, and so you just do that out of habit. Maybe you eat fish on Fridays, and that's a habit of yours. There are ethnic and regional reasons as well for choosing foods. We do like to eat foods that we're familiar with and foods that we grew up with eating, and so often that can determine our food choice. Social interactions, depending on where we are socially, maybe we're at a nice restaurant or we're at a friend's barbecue, we're watching a football game, that can kind of determine what foods might be served, as well as the context in which you may eat them, what kind of manners are expected, etc. Availability, convenience, economy, those are big factors for most people, and definitely can be big factors for students. I know that I mentioned that preference was the number one reason for food choice, but in some situations, money and socioeconomic status actually becomes the number one reason. And this is especially in conditions when money is a limiting factor. Additional reasons. So you may have positive or negative associations with food. Some positive ones for me, foods that I think that make me happy are chocolate, ice cream, birthday cake, something like that. Things that I consider to be had around celebrations, maybe some candy. Negative associations, I like almost all foods, but I don't like wasabi, so maybe I'm going to say wasabi is negative to me. I know for a lot of people, they don't like vegetables, children especially. Ooh, Brussels sprouts, no, that's horrible. I don't like lasagna because my mother always burnt it as a kid, so to me, that's kind of a negative memory when I think about lasagna. Emotions, what are you feeling when you eat? Are you feeling happy? Are you feeling sad? Are you feeling stressed out? Are you feeling like celebrating? Those can definitely dictate some of your food choices. Values, are you choosing a food based on perhaps some of your ethical values, like you're choosing to buy local or organic or non-GMO or maybe non-animal-based food sources? And kind of how do your values influence food choice? Body weight and image, perhaps you are choosing foods because you want to lose weight or become more muscular, become more strong, or have shiny hair or clear skin, things like that. And then obviously nutrition and health benefits. There are many foods that have lots of health benefits for us and are nutritious for us. And those are other factors that go into food choice. Okay, what is a tomato made out of? You're thinking, what are you talking about? Well, foods in general are mostly made out of water. Tomatoes are no exception. And in fact, fruits and vegetables are made out of more water than most other foods. They also have some carbohydrates and a little tiny bit of protein and fat, but mostly they are water. What is the human body made up of? You may be surprised or not surprised to learn that it's water. About 60% of our total body weight is water. And this can vary based on gender, muscle mass, age, etc. But most of the human body is made up with water. So we are kind of what we eat. In addition to water in our bodies, we do have proteins, carbohydrates, and we have minerals in our bodies. Think about the bones and the teeth. Those are made of minerals, as well as there's different minerals that play roles in many metabolic reactions. Body composition. So here you can see a man and a woman compared. And the woman, starting at the bottom, we can look at water. The woman has less water. She has higher percentage of fat and then kind of a small percentage of carbs, protein, vitamins, and minerals. The man has a pretty high percent of water, lower percent of fat, and a higher percent of carbs, protein, vitamins, and minerals. And one reason for this gender difference is that women tend to have higher percentage of body fat, and fat does not hold as much water as muscle does. Men tend to have lower amounts of body fat and be leaner and have more muscle, and muscle is about 70% water versus fat that is about 20% water. Nutrients. So there are 6 different types of nutrients, and maybe you can think of some. I will help list them for you here. Oops, sorry, I didn't list them. I thought they were going to pop up on screen. Carbohydrates, protein, lipids, or some people refer to them as fats, vitamins, minerals, and water. And so now we're going to just discuss a tiny bit about each of these nutrients. The nutrients are made out of elements, and elements are found on the periodic table of elements. So if you've ever taken a chemistry class, you know what I'm referring to. The elements commonly found in our foods are carbon, hydrogen, oxygen, nitrogen, and then various minerals. However, minerals are made up of only minerals. Water is made up of hydrogen and oxygen. Maybe you know water is H2O. Carbohydrates, lipids, and vitamins are made up of carbon, hydrogen, and oxygen. Proteins are also made up of carbon, hydrogen, and oxygen, but they also have a nitrogen group. So that's one thing that separates proteins from some of these other nutrients is they have this nitrogen group. Organic. So chemically speaking, What does organic actually mean? And what organic actually means from a chemist's standpoint is having carbon to carbon bonds or carbon to hydrogen bonds. And in these pictures of these different molecules, the purple circles represent carbon and the small little grayish, kind of greenish circles represent hydrogen. So you can see that these are organic molecules because they contain bonds between the carbons and the hydrogens. What are compounds? So a compound is a substance composed of two or more different atoms. And an example is water, H2O. That's composed of hydrogen and oxygen. How is a compound different than an element? Elements are singular molecules, meaning an element might be hydrogen or oxygen, but compounds are multiple elements combined. Essential nutrients. So there are nutrients that are absolutely essential for life that we cannot make in our own bodies and must be consumed from foods. And there are about 40 nutrients that are currently considered essential with potential for, some new discoveries over time. Energy. Where do we get energy? So we're going to talk in more detail in chapter 2 about energy and what I mean when I say energy, but energy can be measured in something called calories. And certain foods are able to give us energy or calories and other food types are not. Carbohydrates, proteins, and fats are considered energy-yielding nutrients because when we eat them, we're able to make energy from them and we're able to derive calories from them. Vitamins and minerals are different than these because there is no energy found in vitamins and minerals. We cannot use vitamins and minerals as a source of energy to fuel our cells. Vitamins and minerals are still very vital to life. They just don't function as an energy source. So I mentioned calories are how we measure energy. And a calorie is actually a measurement of heat energy. And so we'll discuss in chapter 2 something called a bomb calorimeter. But what they actually do is they burn a small sample of food inside an enclosed chamber. And surrounding this chamber is a layer of water and a thermometer probe into this water. And as they burn the food, they measure how high the temperature of that water increases or changes. And depending on how hot that food, combustion of that food is able to heat the water, we can determine how many calories are in that food. Generally speaking, we use something called kcal or kilocalories. And a kilocalorie is actually 1,000 calories. And even though we use the kilocalories, what most people actually say is calories. 1 kilocalorie is the amount of heat necessary to raise the temperature of 1 kilogram or 1 liter water 1 degree Celsius. So if you were burning a food in this small little chamber while measuring the temperature of the water surrounding the chamber, the food would have to heat the water 1 degree Celsius to have 1 kilocalorie. Some measurements. So measurements are important to nutrition because measuring our food can help us determine how many calories they have, how much energy they provide us, what nutrients they provide us, and in what amounts, etc. We in the United States use kind of funny measurements. We use things like cups and quarts and gallons, but the rest of the world uses the metric system. So I do want you to be familiar with some of the measurements from the metric system. And there are some examples here as well as your book. So for example, 1 liter equals 1 quart, 1 cup equals 240 milliliters, a half a cup equals 120 milliliters, a half a cup of vegetables or solid food will equal 100 grams. There are 2.2 pounds in every kilogram, for example. Okay, so I would want you for this class to be able to identify some food portions and convert our standard American measurement as far as cups go into milliliters. And so in this picture, you have 1 cup of milk and half a cup of orange juice. So hopefully you remembered that 1 cup of liquid milk is 240 milliliters, and a half a cup of liquid orange juice, or whatever the liquid might be, is 120 milliliters. If you are measuring a half cup of a solid food versus a liquid, that half cup of a solid food is going to weigh 100 grams. So grams and milliliters are different. Milliliters are used to measure liquids, and grams and kilograms are used to measure solids. How many calories do we get from each food? So, depending on which foods we eat, they have different amounts of calories that we can derive from them. Carbohydrates and protein both have 4 calories per gram. So if we eat 1 gram of carbohydrates or 1 gram of protein, we can get 4 calories per gram. Fat is very high calorie, and fat has 9 calories per gram, and alcohol has 7 calories per gram, so it is also pretty high calorie. And depending on what mixture of foods you're getting, you're going to get different kind of ratios of these calories. All right, so what are some high protein foods? Hopefully you can think of some. There are animal and plant sources of protein. Just about all plants have some protein, wheat, soy, corn, quinoa, different things like that. Broccoli, spinach, all sorts of things like that. Nuts, beans, legumes also have protein. And then from our animal sources, we have dairy, we have chicken, fish, beef, pork, turkey, and other types of seafoods, just to name a few. What are some high carb foods? A lot of times people think, carbs are just sweets. And carbs do include sweets like cookies and cakes and pastries, but carbs also include things like rice and pasta and bread and cereal grains and, orange juice and grape juice and apples and pears and different things like that. What are some high fat foods? Many animal foods do contain fat, but we also find fat in nuts, in avocados, in olives, there's some in soybeans, whole grains, etc. Things like butter or oil definitely are high fat foods. Do each of these foods I've just talked about only have one nutrient? Hopefully you said no. Most foods have multiple nutrients. We saw that tomato at the beginning, and it had mostly water, some carbs, and a tiny, tiny bit of vitamins, minerals, fats, and proteins, just a tiny bit of those other things. But most foods have multiple different nutrients in them. And so by eating a variety of foods, we can make sure that we're getting all of the nutrients we need. Energy density. So energy density is a concept that is used to compare calories in a food by the weight of that food. And the more energy dense something is, the less full you're going to feel, because you're not going to be eating a big volume or big weight of that food. So for example, on the left-hand side, we have a breakfast with some cereal, bananas, toast, a little bit of eggs, some fresh fruit, and it looks like some tea. That breakfast weighs 450 grams and has 500 calories. So the weight is pretty big. In order to calculate the energy density, you divide the calories by the weight, and in this particular example, you get 1.1. The next meal on the right is 2 donuts and a coffee. And, this is not too untypical at all. And so the donuts don't weigh that much compared to all of the other food on the left. So the donuts and this coffee weigh 144 grams, but they still have 500 calories. And so if you divide 500 calories by 144 grams, you get an energy density of 3.5. And if you compare 3.5 to 1.1, you can see that the donuts are more energy dense. and you probably won't feel as full from eating those donuts as you would if you were to be able to eat all of the food on the left. So this can be a good strategy to compare foods when you're trying to choose things that might help you feel more full. All right. How can we calculate the calories that are available in foods? What do we have to know? Well, we have to know how much food, and specifically how many grams of each nutrient there are in the food. So how many grams of carbs, how many grams of proteins, how many grams of fat. And the reason we have to know that is because, remember, protein and carbohydrate both have 4 calories per gram, but fat has 9 calories per gram. So for an example, I could give you an example. A slice of bread with peanut butter might have 16 grams of carbohydrate, 7 grams of protein, and 9 grams of fat. And so what you might do is you could multiply the 16 grams of carbs by 4 calories per carb. You would multiply the 7 grams of protein by 4 calories per gram protein. You would multiply the 9 grams of fat by 9 calories per gram fat, and then you would add up the sum of all those numbers to find out how many calories the food had. All right, review. Where does food energy come from? Carbs, proteins, fats. Where does that energy go? So we haven't quite talked about this yet, but what do we do with the energy we get from foods? We can do a lot of things. We can make new cells. We can make immune factors. We can move our body. It can be physical energy that we use to power our muscles. We can produce heat and keep ourselves warm. We can store it for later. We store energy as fat. And so we can do many, many, many things with the energy that we get from the foods that we eat. Vitamins. We're going to talk about the vitamins in much more detail later in the course. So this is just a very, very, very brief intro. Vitamins are organic. Hopefully you remember that means they have carbon-carbon bonds or carbon-hydrogen bonds. They do not provide energy, so there are no calories in vitamins. We just reviewed the nutrients that do have vitamins in there. They help us process foods to release energy. So we're going to learn about vitamins coming up, but vitamins often act in metabolism as something called cofactors. And in metabolism, they allow us to break down our food to the smallest components and create energy from that food. So although the vitamins don't provide energy themselves, they are very crucial to our bodies being able to get energy from foods that we eat. And how many vitamins are there? There are 13 different vitamins. There are 8 B vitamins as well as vitamin C, and these are considered water soluble. And then there are the fat soluble vitamins A, D, E, and K. And we're going to discuss some of the differences in fat soluble versus water soluble vitamins in the future chapters. Maybe you know a little bit about vitamins already. Many people do, just from their everyday life and kind of remedies that perhaps have been passed down through moms or grandmothers or fathers. So which vitamin helps support a healthy immune system? Hopefully you said vitamin C. Which vitamin is important for good eyesight? Vitamin A. Perhaps you had parents saying, eat your carrots, it's good for your eyes. Well, carrots have a precursor to vitamin A in them. What vitamin, along with calcium, helps to build strong bones and teeth? You might not know this, but there's actually a vitamin called vitamin D that we get from the sun that is crucial to our bone and teeth development, as well as many, many other functions. And this vitamin is cool because not only can we make it when we go out in the sun, but we can also get it from food sources. Minerals. Minerals are not organic, so that means that they do not necessarily have these carbon-carbon or carbon-hydrogen bonds, which the vitamins did have. They do not provide energy, just like the vitamins. They do help make some of the structures in our body. For example, our bones and our teeth are made of minerals, and they're also very important to different bodily fluids. And there are 16 essential minerals, some that are non-essential and some that are even toxic. So for example, lead is toxic, aluminum is toxic, mercury is definitely toxic. Those are some toxic minerals out there. But things like iron, phosphorus, potassium, magnesium, sodium, those are actually very important to life. Water. Hopefully you know that water is important. Water is not organic because if you remember what water is H2O, which means it is a hydrogen and two oxygens. So in this water molecule, you don't see any carbons, and so therefore it is not organic. So if you get a bottle of water and it says organic on it, technically from a chemist's point of view, that's not true. Water is very important for us, though, and plays a part in many reactions. It helps our body regulate heats. It serves as a fluid for different things, such as our saliva, our tears, our cerebral spinal fluid. It serves as a lubricant for joints. It helps carry different solutes within our body, and it helps make up things like our blood and our lymph fluid. What types of nutrition topics have been in the news lately? You know, I'm not totally sure what's been in the news lately, what people have been seeing. I've been hearing a lot about paleo diets, although this isn't the first time they've been in the news. I've been hearing more about ketogenic diets in the news. So to me, that's what I've been seeing in the news. I don't know what you guys have been seeing or reading in magazines or online, but that's what I've been seeing. How do things make the news? That's a good question. Often they begin with a question or what's called in the scientific community a hypothesis. And so in the scientific community, a hypothesis is an educated guess or an educated question. So for example, you might say, what foods or nutrients help fight off the cold? And you could make a hypothesis that says, well, maybe foods with vitamin C help fight off the cold. The scientific method is very important to nutrition science and helps us kind of come up with the answers to these very important questions that we ask. The first parts of the scientific method involve observation and question. We observe that people get colds. We observe that people who drink a lot of orange juice and eat a lot of citrus maybe have colds for a shorter period of time than people who don't. We then make a hypothesis. Maybe it's something in the orange juice and citrus, such as vitamin C, that helps reduce the average time people have a cold. We can then conduct an experiment. Let's give one group of people vitamin C supplement and the other group of people a placebo, or what's called a sugar pill. That means it does not have any vitamin C in it, but it looks the same as the pill that does have the vitamin C. We can then follow these people for, say, a year or two and see who gets colds, who doesn't get colds, how long they have colds, and then we can interpret the results. If we see that there is no difference between the group of people who got the vitamin C and the group of people who got the placebo, we would not be able to prove our hypothesis. But if we see that the people who got the vitamin C maybe had colds for a shorter period of time than the people who got the placebo, we could support our hypothesis. And then we could develop a theory that says we believe that vitamin C reduces the time for a cold. This would be just one example of how the scientific method could be applied. There are many different types of research in nutrition, and I do like to give a disclaimer that nutrition research is very, very, very complicated, even in the best case scenarios, and that's because there are so many confounding variables as well as differences in every single human. So there's a lot of issues with nutrition-related research. However, there are some foundational kind of establishments that are the basis for research. So for example, having two groups, a control group versus an experimental group. In the hypothetical research I just discussed with the vitamin C, the experimental group would be getting the experimental item in question. So the experimental group would be getting the vitamin C supplement. The control group would be getting the placebo pill or the sugar pill. And the control group helps you determine, helps you rule out what's called the placebo effect. Sometimes when people are told that they're given a pill, they automatically feel better just because they believe they will feel better and this pill is curing them. And so a placebo group or control group helps rule that out. There are epidemiological studies, which we're going to talk about on the next page, and there are experimental studies, which we'll also talk about on the next page. These are different types of studies that you can read about in your book, but there's cross-sectional, case control, and cohort studies. There are also laboratory-based studies on rats or small animals such as monkeys or rodents. There are in vitro studies, which involve test tubes or petri dishes in a lab. And there are human trials or clinical trials, which involve actual human subjects. Human studies are very strong sources of scientific information. However, they're also very expensive, very costly to do, and there have to be a lot of ethical and safety questions answered before you can just begin a human trial, because you wouldn't ever want to give a human something that could possibly hurt them or lead to worse health than what they started with. Some important research terms that, again, you can look at in your book. I would definitely review these so that you feel comfortable understanding what they are. DRIs. So the DRIs are the dietary reference intakes, and these are a set of recommendations and numbers kind of established by scientific research as well as government bodies. And so we're going to talk about all of them coming up. They include, so the DRIs include 4 sets of recommendations. So they include an estimated average requirement, a recommended dietary allowance, adequate intake, or a tolerable upper intake level. Adequate intake, this is sometimes abbreviated AI. And an adequate intake level is the average amount daily that appears to be sufficient to maintain a specific criterion and is used as a guide for nutrition intake when RDA can't be established. So we're going to talk about RDA coming up, but in order to establish an RDA, you have to perform extensive scientific research and have a lot of contributing facts and information to establish an RDA. AIs are established when you don't have adequate evidence to establish an RDA. RDA. So RDA, the average daily amount of a nutrient considered to be adequate to meet the known needs of almost all healthy people. So this will meet the needs of about 97 to 98% of the population. And this is a goal that people should strive for. So you should try to consume as much as the RDA. The RDA is established based on scientific evidence and is actually established based on something called the EAR, which we're going to talk about coming up. And the RDA does apply to healthy people, so this does not apply to sick people, injured people, etc. And RDAs are specific for different age groups. For example, there are RDAs for infants, there are RDAs for middle age, there are RDAs for elderly, and there are also RDAs for men and women. EAR. EAR would be the first piece of scientific information that is established, and this would be the amount of nutrient needed to meet half the population's goals. So you wouldn't want to strive for the EAR, but you would want to strive for the RDA. I really like this kind of diagram because it is looking at risks of inadequacy as well as risks of adverse effects. And it can help explain all of these DRIs that I've talked about, as well as this UL, which is the last one. And the UL is the maximum amount of a nutrient that appears safe for most healthy people and beyond which there is an increased risk of adverse health effects. So the UL, or upper limit, is the most that you would want to eat on a daily basis of a certain nutrient. And as you get beyond the UL, your risk of adverse effects or nutrient toxicity increases. RDA is going to meet the needs of about 97 to 98% of the population. So if you can see on the left-hand side of the screen, this is actually a half of a bell curve, and bell curves are used to represent populations. Bell curves have something called deviations, standard deviations, and the RDA is 2 standard deviations on this bell curve. So that will meet the needs of all of these people that I'm coloring in red. And the EAR will meet the needs of about half of the people. So anything, the RDA only misses a very small segment of the population, and the EAR misses about 50% of the population. Energy recommendations. There are a set of recommendations that are kind of complementary to the dietary reference intakes, and these are called the AMDRs. And these are general ranges for carbohydrates, fat, and protein for these macronutrients. And what they're saying is that you should have 45 to 65% your total calories from carbs, 20 to 35% your total calories from fats, and 10 to 35% your total calories from protein. And these are pretty wide ranges, and so for each person, where they fall within these ranges would be pretty different. How do we use some of these recommendations? So one key is to remember these apply to healthy people. These do not involve sick people. They do not apply to specific populations. For example, there are specific recommendations for pregnant or lactating women. And they are not minimum requirements. They should be met by consuming a variety of foods. And so diversity within your diet is very important. And I think also something important to see here is foods are the best source of nutrients versus supplements. What happens if somebody does not get enough of the nutrients his or her body needs? Well, undernutrition can happen. Disease, poor healing, decreased immune function, anemia, tooth disease, bone disease, everything like that. What happens if somebody gets too much of the nutrients they need? Well, toxicities can happen. If you're consuming too much of some of the micronutrients, we will store the majority of those as fat, and so weight gain can also happen. Malnutrition. The word malnutrition, sorry. The word malnutrition literally means bad nutrition. It doesn't specify over or undernutrition. It just means bad nutrition. And so, sorry, I've been coughing a little bit. Malnutrition can include either undernutrition, meaning not enough, or overnutrition. And it is actually possible for somebody to be both under and overnourished. For example, people can be obese, meaning they are overnourished as far as calories go, but they can have nutrient deficiencies. For example, they may not have enough calcium or vitamin D or vitamin C. How can you tell if somebody is malnourished? Well, you can't always tell by looking, but sometimes you can. But in general, you would want to do a complete nutrition assessment. And so we're going to talk about some of the components of a nutrition assessment. You would want to ask them historical information, so health status, socioeconomics. This has to do with income, diet, or drug use. So perhaps you would do a 3-day food recall. Tell me what you've eaten for the last 3 days, or tell me what you've eaten for the last 24 hours, or tell me what you usually eat. first thing in the morning, then next, then next, then last thing before you go to bed. What drugs do you use, both prescription and over the counter? You could do some measurements. You could do height, you could do weight, you could do waist circumference. You could do percentages of lean body mass versus fat distribution. You could do some measurements such as those. You could do a physical exam. So I said sometimes you can see malnutrition, sometimes you can't, but you might be able to find hints of malnutrition by looking at the hair, the eyes, the skin, the posture. Somebody hunched over perhaps due to severe osteoporosis or something like that, or do they have good posture? The tongue can actually demonstrate some nutrient deficiencies, as well as the fingernails. You could also run some tests. So you could measure their blood. You could look for different components in their blood. You can measure their urine. You can even do stool samples if you wanted to examine perhaps which bacteria were living in their intestine, or if there was any blood in their stools. Nutrient deficiencies. So nutrient deficiencies can be kind of categorized based on why they occur and then their severity. A primary nutrient deficiency is a nutrient deficiency that occurs because you're simply not eating enough of that nutrient. For example, calcium deficiency is very common, especially in young children. Adolescents, and it's because they're not eating enough calcium-containing foods such as milk or dairy or calcium-rich vegetables. A secondary deficiency is a deficiency that develops because of some sort of disease or condition that reduces your ability to either absorb a nutrient, increases or accelerates your use of that nutrient, or destroys the nutrient itself. So, for example, in kidney disease, the kidneys are involved in helping you activate vitamin D from the sun and converting it into something that your body can use. But in kidney disease, because the kidneys aren't functioning as well, you can't make enough vitamin D when you go out in the sun. And so vitamin D deficiency is very common. There is something called a clinical deficiency and a subclinical deficiency. A clinical deficiency is seen not only in physical appearance, but also in lab work. A subclinical deficiency is a deficiency in the early stages. And this is before you can just look at somebody and say, oh, you have scurvy, vitamin C deficiency, or you have anemia, iron deficiency, etc. You have rickets, vitamin D deficiency. Some subclinical deficiencies can be categorized as either overt, meaning they're hidden, or covert, meaning hidden or overt. Depending on what you are observing in the body, there will be different parts of the nutrition assessment that can help you kind of unlock some of the clues. So, for example, diet history and health history will help you to gain information about primary or secondary deficiencies. Laboratory tests will help you to gain information about nutrient stores and abnormal functions. And then a physical exam, as well as some of the measurements I mentioned, will help you to gain information about physical signs and symptoms. Nutrition assessment of populations. So we have, through our government, conducted many nutrition assessments of populations, and some of the data gained in these assessments has been used to make regulations on nutrient requirements, recommendations, intakes, etc. There are national nutrition surveys, and these are surveys related to areas of research, various different federal agencies, and they collect data on types of foods as well as how much foods people eat. There's something called the National Health Goals, Healthy People 2020, which we're going to talk about. They set policies and guide policies every 10 years. And then there's national trends in different foods, where you would look at what's happening kind of on a country basis. Are people eating more fast foods? Are people eating less fast foods? Are people consuming more calcium-rich foods? Are they eating less calcium-rich foods, etc.? This is from your book, and this is just one part of the Healthy People 2020 goals. This specifically is looking at nutrition and weight status objectives, but there are many other parts of nutrition, Healthy People 2020 goals. Some examples of some of the goals are increase contributions of whole grain to the diet, eliminate low food security among children, reduce proportions of children who are overweight, increased percentage of schools that offer nutritious foods and beverages. What are some of the leading causes of death in the U.S.? Maybe you can think of some that your family has been subjected to, unfortunately. If you can think of some of the leading causes of death in the United States, many are actually nutrition related, whether in a direct role or indirect role. So in the United States, number one killer is heart disease, cancers, lung disease, stroke, accidents, Alzheimer's disease, diabetes, pneumonia, kidney disease, and suicide. And depending on what chart you look at, sometimes you see stroke a little bit higher, or sometimes you see stroke clumped with heart disease. The ones in bold are considered to have nutrition-related risk factors. So, for example, heart disease and stroke are absolutely related to dietary intakes, high blood pressure, obesity, metabolic syndrome, cancers. Some cancers have a nutritional component, definitely colon cancer, breast cancer, stomach cancer, esophageal cancer, etc. Diabetes absolutely has a nutritional component. And then I would argue that kidney disease also has a nutritional component, because the number one cause of kidney disease is actually diabetes, and the number two cause of kidney disease is high blood pressure. And those are both nutrition related. So I personally would argue that kidney disease as well is nutrition related. Excuse this writing here. Risk factor. So a risk factor, a condition or behavior associated with an elevated frequency of a disease, but not proved to be causal. So this means that if you have a risk factor, there is a strong association with a certain disease, but that doesn't necessarily mean that because you have this risk factor, you are going to get a disease. It just increases your chances. And so some examples, obesity, smoking, high blood pressure, high cholesterol, physical inactivity, diets that are high in fat, low in vegetables, low in fruit, low in whole grains, alcoholism, increased consumption of sugar-sweetened beverages, poor dairy consumption, things like that. There are some risk factors that we can change, and there are other risk factors that we cannot change. We can change our diet as well as our activity and lifestyle behaviors, such as smoking and alcohol. And hopefully by the end of this class, you'll learn some tips, especially for diet and activity. We won't talk about alcohol or smoking that much, but smoking is a pretty no-brainer. If you do smoke, trying to quit is very, very good. And then alcohol, if you do drink excessively, trying to cut back. Some things we cannot change. So we can't change our genetics or our heredity or family history. And unfortunately, with many of these diseases, if our family has history of these diseases, our chances of getting these diseases is also higher. We can't change our gender as far as risk factors are concerned, and we can't change our age. And older age often seems to be an increased risk factor for many of these diseases. In the United States, percentages of some of these risk factors leading to death. So smoking, tobacco alone contributes to 18% of death. Poor diet and activity, right behind smoking, number 15. I'd actually be surprised if this has not flipped, because this is from 2000 and then was corrected in 2005. So this is slightly old data from our text, but I wouldn't be surprised if poor diet and inactivity is number one. Alcohol, number 4% of deaths, microbial agents, 3%, toxic agents, motor vehicles, firearms, sexual behavior, and drugs. But diet and inactivity are very high up on this list. How often do you think of health and nutrition when making food choices? I know that I at least think of them almost every day. That doesn't mean I always act on them, but I do think about them. Whatever your frequency is, I promise by the end of this class, it will probably be higher. And I think that's a good thing. It's always good to think about, and it's your choice whether you're going to act or not. Which disease risk factors do you have? During this class, we're going to be doing an assignment called a health tree, a family tree, and we're going to be looking at your family history and your family risk factors. We're also going to ask you to just, examine kind of your personal life. Are you being active enough? Are you eating healthy? Are you smoking or using drugs, etc.? And then what lifestyle changes could you make to improve your chances of enjoying good health? So we looked at those modifiable risk factors, and by identifying some of those that you may be able to change, you could potentially increase your lifespan as well as what's called your health span, or the number of years that you live a healthy, productive life. There are some highlights in your book at the end of each chapter, and they may not directly have to do with the chapter, but they're still interesting topics in nutrition, so we will cover them kind of briefly at the end of each chapter. And then I also have some trivia questions, which you are very, very likely to see again, either on your quizzes or final exams. So, true or false? Everything on the internet is accurate and up to date. Hopefully you said false. Claims made in television and magazine ads for diet products are always trustworthy. False. All celebrities are nutrition experts. Oh no, false. Hopefully you said false, false, false. So who are the nutrition experts? Registered dietitians, or what's now called registered dietitian nutritionists, are considered nutrition experts. And a registered dietitian nutritionist has to have a 4-year degree from an accredited university, as well as has to attend a dietetic internship that's usually 1 year in length, and then sit for a dietetic exam that's comprehensive, and maintain yearly continuing education to keep up their knowledge, keep their knowledge current and accurate in the field. Dietetic technicians are also nutrition experts. They have a slightly lower education requirement than registered dietitians. They can have a 2-year degree and then sit for the dietetic technician exam, as well as they do not have to do as strict of an internship. And then the Academy of Nutrition and Dietetics is a great resource for nutrition information as well. Some doctors are great resources for nutrition. However, most med schools do not require doctors to take any nutrition classes, and the ones that do generally have the doctors taking one nutrition class. So some doctors may be great nutrition experts, and some doctors just haven't had the education in that area specifically. Same thing with nurses. Some nurses may be very skilled in the area of nutrition, and some may not. And same thing with just any other type of practitioner. How do you know if a website is reliable? Well, you want to answer some questions. And I have a very good example in the text that helps you evaluate a nutrition website. So who is the website written for? And who wrote it? Did a doctor write it? Did John Doe write it? Did Jenny James write it? Do they have credentials? When did they write it? Is this website from 1980? Probably not, because the internet wasn't really existing then. But, is the website from 2003 or is it from 2018? Where? Is the website part of a government site? Is it free to the public, or is it found, on perhaps a product web page where they're selling things? Why was their website written? Are they trying to sell things? Are they trying to educate you? Are they trying to change your mind or influence your nutrition choices in a certain way? And what's it talking about? So there's a lot of questions to ask when evaluating websites for their accuracy as well as reliability. Identifying misinformation. Oops. So how can you identify misinformation? There's a lot of different ways, and actually the visual on the next page will kind of help us identify some misinformation. Products that claim it does everything. Products that claim they are quick fixes. Products that claim they are time tested or they're new treatments. Personal testimonials, those are the weakest forms of evidence. Phony terms, so beats the hunger stimulation point. That's not even a thing, that's made up. Talking about things that are not even a thing. Natural, this does not mean anything. The word natural found on a product doesn't mean anything. There's no regulating body to dictate what natural means. Satisfaction guaranteed or your money back, results in 10 days. These are all kind of scam type things. This product is trying to convince you to buy it, and really there's probably no proof behind it. So you have to be very wary of nutritional products and information that's out there. Trivia. All right. When people eat the foods typical of their families or geographic region, their choices are primarily influenced by D, ethnic heritage or tradition. Both the human body and many foods are composed mostly of B, water. Inorganic nutrients are minerals and water, because remember, there are no carbon to carbon bonds or carbon to hydrogen bonds. Energy yielding nutrients are, this means they give us calories, carbs, fats, and proteins. Studies of populations that reveal correlations between dietary habits and disease incidence are called epidemiological studies. An experiment in which neither the researchers nor the subject know who is receiving the treatment is known as, so this is known as a double-blind experiment, and I didn't talk about this, but in a double-blind experiment, there will be a control group and an experimental group. Remember, the control group will be getting a placebo pill. The experimental group might be getting whatever supplement they're testing, say if they're testing a supplement. And the patients who are receiving these treatments, whether it's the control group or the experimental group, they won't know what they're getting. And the researchers will not know who is getting what. And the reason double-blind placebo control studies are very strong is because they eliminate a lot of bias. They eliminate the bias from the placebo, as well as they eliminate researcher bias. The researcher might want a specific outcome to happen. But if the researcher doesn't know which group is getting treatment versus which group is not, the researcher can't kind of influence the outcome if it's a blinded study, double blind. RDA. So what does an RDA represent? An RDA represents the average amount of a nutrient considered adequate to meet the known nutrient requirements of almost all people, or practically all people. Historical information, physical exams, laboratory tests, and anthropometric measures are methods used in a nutrition assessment. A deficiency caused by an inadequate dietary intake is an primary deficiency. Behaviors such as smoking, dietary habits, physical activity, and alcohol consumption that influence the development of disease are known as risk factors. Okay, class, hope you enjoyed that lecture. That was just a small intro, and I will talk to you soon. Thank you for listening. Bye.